In the enterprise segment, there is a long-standing demand for more capacity. The drivers are different from vertical to vertical, but in general, there's a desire to have more devices and more bandwidth and lower latency, just as we see in the cellular service, cellular networks.
Hello, this is Martha DeGrasse here for Wi-Fi Alliance. And this is The Signal, our podcast where we give you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders, and we want to deliver a new perspective for you on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. In this episode, we'll be talking about the current state of Wi-Fi 6E and how the adoption of different device classes affects migration strategies for enterprises, as well as what companies need to be thinking about and doing now to evaluate and prepare for Wi-Fi 6E. So joining us to discuss all of that and more is Chuck Lukaszewski. He is VP and Wireless CTO of Aruba, a Hewlett-Packard enterprise company. Chuck, thanks so much and welcome to The Signal.
Thanks, Martha. Glad to be here. Thanks for having me.
Well, I think we should start off at the broad level. A lot of people have become aware of Wi-Fi 6. Now we have Wi-Fi 6E. So can you give us an overview of what this is and why there's so much excitement?
Absolutely, I'd be happy to. So Wi-Fi 6 is, of course, the most recent generation of Wi-Fi technology. For those folks with a technical bent in the audience that track what the IEEE designations are, that's 802.11ax. And Wi-Fi 6E is Wi-Fi 6 for the new 6 gigahertz band that has opened up in a significant number of countries, with more on the way. So Wi-Fi 6E is still Wi-Fi 6. It's that same technology, but it's a set of sort of extensions and additional features that support the new 6 gigahertz band.
Okay, and just in case anybody's not aware of all the new tech that Wi-Fi 6 brings, can we do a quick review of that?
Yeah, absolutely. So the defining feature of Wi-Fi 6 is its multi-user capabilities. We got a little bit of multi-user in Wi-Fi 5, but in Wi-Fi 6, it's really very complete. There are two different major technologies that have multi-user components, and they can work in both directions. So the first is something called OFDMA, which many of your listeners may know about. This is very similar to technology that's used in the 4G and now 5G cellular phone systems to be able to transmit simultaneously, either in the downlink or uplink direction, to dozens potentially of devices, up to 37 different devices at the same time. And then there's a separate technology called multi-user MIMO, and that's used for much bigger kinds of information. So think video as opposed to voice. And that also can be used to send traffic to multiple stations at the same time. So this is a way to really use airtime much more efficiently, right? So instead of having to have, essentially just a one-lane road, you can move lots of different lanes of traffic down the road at the same time. Beyond the multi-user features, there are some improvements around energy management for devices. It continues the march towards more and more efficient use of what we call the medium, right? But essentially the wireless medium. And it's being adopted very quickly by the market. It's Wi-Fi 6 adoption. Each new generation of Wi-Fi has, if you just look at the shipment data, right, has been adopted more quickly than the last. That's as much true as of Wi-Fi 6 as it has been in the past. Okay,
great. And all these new technologies clearly are going to lead to more bandwidth use. So therefore, more spectrum is needed. So let's talk about the advantages of this additional spectrum. I believe it's 1,200 megahertz altogether in the band.
Yeah, exactly. And one of the features that I sort of left out for this next part of the conversation is the wider channels. So as opposed to the previous generation, which had predominantly, I think there was Wi-Fi 5 supported 160 megahertz channels in some equipment, and it certainly did 80s. With Wi-Fi 6, it becomes much more practical to use these bandwidths. And so in turn, it's hard to do these large channels if you don't have a lot of spectrum to work with. And most countries, right, it varies a little bit from country to country, from region to region. But in the 5 gigahertz band, historically, we've only had somewhere between 20 and 24 20 megahertz channels. So that's about 400 to 480 megahertz of spectrum. If you have a technology that can do these really wide channels, but you don't have enough spectrum to use them, right, then what happens is you end up using much smaller channels. And that's what we found. And I think the other, large device manufacturers. So we published some data last year that about a little over 90% of Aruba customers today are using 20 or 40 megahertz channels in the 5 gigahertz band. And that's really unsatisfying for us as a manufacturer because the technology is capable of so much more, right? But we just don't have the spectrum to use it. So what's so exciting about 6 gigahertz is, as you alluded to, there are two different kind of models of the amount of spectrum that's being opened up. There's what I call the Americas model, and the other is the kind of the European model. So in the Americas, as you say, it is 1,200 megahertz of spectrum, which is just completely unprecedented. It's almost 3 times the amount of spectrum that we had up until this point. But even in the European model, it's 500 megahertz of additional spectrum. That's on top of the spectrum we were just speaking about. So it really does start to become possible to use 80 megahertz channels by default, or even potentially 160, depending on your application. And that's going to open up tremendous it's going to lower latencies. It's going to, increase bandwidths, and also we may talk about this later when we get to how this actually deploys in real enterprise environments, but it's going to give wireless architects some choices that they've never had before in terms of how to actually deploy this spectrum for different kinds of needs.
Okay, excellent. So in terms of getting access to that 6 gigahertz band, where do we stand as far as the number of countries that have approved that, roughly?
Absolutely. So, this is a number that kind of changes certainly by the month, some days by the week. So where we sit right now is there are 47 countries that have taken a legal decision to actually open the band now. And those countries, they might follow one or the other of those two models that we were just talking about, but they have administratively made it possible for equipment manufacturers like Aruba to actually ship product into the country, right? Beyond the 47 countries, there's about another 40 that are in some stage of a regulatory process that will result in opening the band. So by sometime next year, we're looking at somewhere north of 90, maybe as many as 100 countries that have, again, made it possible to ship 6 gigahertz equipment into their markets.
Okay, great, thanks. And the Wi-Fi Alliance also has a tracker on its website with real-time updates on countries that are enabling Wi-Fi 6E. That can be found at wifi.org. That's wi-fi.org. We are taking a short break to remind you that you can find resource information on today's episode about Wi-Fi 6E in the show notes and at our website, wi-fi.org. You can also contact us there on the site and learn even more about Wi-Fi Alliance. If you like what you hear, take a second to subscribe to The Signal wherever you get your podcasts for all of our episodes. All right, back to Chuck. So it sounds like, Chuck, this is maybe more of an enterprise play than a consumer play. So can you talk to us a little bit about what enterprises need to be thinking about as they look at Wi-Fi 6E?
Sure. So just to be clear, right? I mean, consumers are going to be huge beneficiaries of this, but in terms of the markets that Aruba serves, right, we're one of the largest providers of managed Wi-Fi systems to enterprises and service providers. So in the enterprise segment, there is a long-standing demand for more capacity. The drivers are different from vertical to vertical, but in general, there's a desire to have more devices and more bandwidth and lower latency, just as we see in the cellular service, cellular networks. So for example, in the higher education market, if you think about a lecture hall, right, that has chairs for 200, 300, 1,000 students, all doing some kind of e-learning, right? Maybe classroom presentations. They're doing testing online and so on. Multimedia. So there's a real need to be able to deliver higher capacities there. And then something as mundane but as important as where the students are living, right? If it's a campus that has housing on it, right, is dormitories, right? And people want to game and they want to browse the internet and be social with their friends and do VR and what have you. So, we have the universities are kind of an interesting mix of these different use cases. And that's even before we get to the stadiums and arenas that exist in these environments. So, that are ultra high density deployment. So that's kind of a very interesting, kind of leading edge use case. And we're seeing a lot of take up. We announced a product a few months ago, our first 6E product, and we're seeing very good adoption in the higher education space specifically for that. If you look at K-12, just to kind of round out education, there is no less of a need for younger kids, than there is in maybe the college or university world. But the need is a little different. So in that case, you have what are called one-to-one initiatives happening, where essentially the goal is to get a laptop or tablet into the hands of every child in every level of education. And so each classroom is kind of its own high density network. And if you think about these classrooms side by side with each other, typically each of them is going to have an access point in it, and they are congested. They are constrained by the amount of spectrum that's available for the experience, the kinds of services that they can deliver to students. So that's another exciting area. If you look at healthcare, we're super excited about all the different applications that 6E makes possible in a hospital or a clinical setting. Hospitals are one of the original adopters of Wi-Fi as a technology. It's a very low cost way for them to deliver wireless functionality for a wide range of use cases, not just for the clinical staff, but also, of course, for patients and their guests. So we're seeing strong pickup there. And I could go on, but basically all the verticals that use Wi-Fi today, we expect to have 6E will resonate strongly with.
Okay, great. I read some of your research about how hospitals are starting to use this technology and really segregate those different use cases. And I believe that there's also different APs or different device classes for different uses. Is that correct?
Yes, that's exactly right. So the rules in 6 gigahertz are a little different than what folks are used to in the traditional Wi-Fi bands. In the Wi-Fi bands today, we have really only two kinds of access points and one kind of client. So the two kinds of APs are essentially whether they support what's called dynamic frequency selection or DFS or not. And that's dependent on the channel. So if I want to use a certain set of channels, I don't need to follow the DFS rules. If I'm going to use these other channels, then DFS is required. And so in that sense, it's the same physical AP, but it has these sorts of two states that it flips between. So with 6 gigahertz, it's going to be much more complex than that. And the reason has to do with the nature of who we're sharing the bandwidth, right? So Wi-Fi is a technology that shares the band with existing incumbents. We don't have spectrum that's dedicated just for Wi-Fi or other kinds of unlicensed uses. And in this band, we are sharing with some very critical services. The primary ones are point-to-point microwave systems that are used by an incredible range. They're used by public safety agencies, and they're used for transportation. Think about railroad siding, railroad data communication networks, power utilities, and more. And then there's some fixed satellite services in this band. So what those have in common is they're all outdoors. And so in order to make this band available for Wi-Fi at the soonest possible time, what the regulators have decided, starting with the US FCC, is it made sense to create a type of device class that was called low power indoor. And that device is the way that it protects these incumbents that we were just talking about is really through two primary mechanisms. There's some others, but the two that matter the most are, first of all, that it must be indoors, and therefore the building walls and the ceiling and so on provide a significant degree of protection from potential interference. And then secondly, these APs have to work at a lower power limit than what's expected to be made possible for outdoor equipment in the future. And you put those two things together and you have this class called low power indoor. Then there's a class called very low power, which many countries, the US has not done this yet, but many countries, for example, in Europe have approved this device class. And these are even lower power than we were just talking about. And the use cases are for things like tethering from your phone, right? If I want to connect with, I have AR goggles and I want to talk to the phone, or maybe I have an AP in my car, right? Something along that line. So super low transmit power, but these devices are mobile and they can go indoors and outdoors. So we don't have those walls to count on. And then there's a third class, which is called standard power. We can talk about that more if you're interested. These would be for APs, Wi-Fi APs that are literally physically deployed outside. And so they need some additional protections to protect those incumbents.
Okay, yeah, that's super interesting. And I'm really glad that you went over all that. So from an enterprise perspective, how can an enterprise think about starting into all this? I'm guessing it's the low power indoor APs that the enterprise will focus on first, maybe?
Yes, that's exactly right. So the countries that we talked about earlier, the device class that they've authorized is in every case low power indoor, and we'll just call it LPI for short here. And then, some countries have, as I said, approved VLP, but VLP really is not an enterprise use case. So in the enterprise, yes, it's very much LPI. I think those are the products that are starting to come to the market from companies like ours. So those use cases I was just talking about in the lecture hall at the university, right? The classroom at the middle school, what have you, the hospital. These are all LPI use cases where essentially you're going to deploy Wi-Fi 6E AP in place of the previous generation APs that had been on the ceiling in pretty much the same locations.
Okay, so it sounds like Wi-Fi 6E would be maybe part of a refresh when it's time for a company to do a refresh.
That's exactly right. In general, the power levels, one of the first questions I get from customers that are considering an upgrade is, do I need to pull more cable? Do I need to be changing anything about my radio design? And the simple answer to that is no. The power levels that have been permitted, again, in the enterprise are more than adequate so that we can match the coverage of, if you think about a 6E access point with 3 radios in it, right? I've got a radio in the 2 legacy bands as well as the new 6 gigahertz band. We can match the coverage of all 3 radios to kind of have the same cell edge.
Oh, okay. Well, before we finish, can you talk a little bit more about how companies that have all these, they have their legacy Wi-Fi and now they're adding on 6E. Can they still use all of it and use it for different purposes, or will they just put everything onto 6E?
That is a really interesting question. And I think the answer to that is going to vary from customer to customer, right? Just to use it in my terminology. I think there will be a number of enterprises, certainly more in the small business, medium business type category, that will simply use 6 gigahertz in the same way that they're using the other bands. And so what that means is that all the channels that are available will be sort of treated as a single block of capacity, just as they are in 5 gigahertz, for example. And then the decision is, okay, which SSIDs go on which bands? And for those in the audience, if you don't know what an SSID is, that's the name of the Wi-Fi network that you see on your device when you're looking for Wi-Fi. And you do start to have some interesting choices here. So if I'm an enterprise architect, I could choose to have a 5 and 6 gigahertz SSID. I could also choose to have a 6 gigahertz only SSID, right? If, to your point, if I wanted to just reserve 6 gigahertz for certain kinds of devices that the organization has paid for. And you could even envision, there's been a lot of talk for years about, okay, what is the future of the 2.4 band?
Yeah.
And with 6 gigahertz being here and being real now, one could envision reallocating the spectrum inside enterprises and making 2.4 a band for IoT. So you're still running Wi-Fi, but maybe you're only using it for cameras and sensors and other kinds of headless devices, and you're using the 5 and 6 gigahertz bands for devices that have screens or need higher capacity.
Excellent. Well, there's a lot to look forward to. All right, Chuck Lukaszewski, VP and Wireless CTO of Aruba. Thank you so much for being here on The Signal.
You're welcome. Appreciate the invitation.
That's it for this episode of The Signal. Don't forget to check the show notes for links to resources we discussed today, including the 6 gigahertz tracker with real-time updates on countries that are enabling Wi-Fi 6E. So for all Wi-Fi resources, including Wi-Fi 6E, don't forget to visit Wi-Fi Alliance, that's wi-fi.org, or connect with us on social. I'm Martha DeGrasse. Until next time, thank you for listening to The Signal.